Hey everybody. You probably already figured this out by now, but this is a programming course. This is not a hardware course. So, don't ask me what are all the different kinds of processors, what are the differences between them, what are the different modules, I/O and output, what are the differences, how much do things cost, how do I order it. That's not my job. I don't do those things. But I do want to dip a toe into hardware because this is somewhat relevant to the programming, and it's something basic that every PLC programmer is going to need to know, and that is setting up I/O modules. The digital modules, digital input and digital output modules, there's really not a lot of setup to that. You drag the thing in there, you wire up your devices, and okay, you're done. The channel's either open or closed. But for analog, there is a little bit to know. There are different signals coming in, and you have to know how to configure the module for each of those signals. Also, whenever you're either getting a signal in from an input on the input module or you're sending a signal out through an output module, you're going to have to do some scaling. And that means you're going to have to know what the range of numbers is that these modules are working with, okay? So that's pretty easy. We're going to look at one module, and I'm going to show you the manual. This manual is included in your documentation bundle that you downloaded from Lecture 2. So you've got a copy of this manual, even though every input-output module, every one has its own manual. So does that mean that the scaling on this is exactly the same as every other module? Not necessarily. So just be familiar with this. I want to show you how to find what you need for whatever module you happen to be working with, and I want to show you how to deal with the scaling. If at this point you don't know what scaling is, don't worry, okay? You're going to be up to here in scaling by the end of the course. You're going to know all about that. But long story short, we have analog signals coming in and going out. Those signals are going to represent things like temperatures and pressures and speeds and RPMs, and we need to know what the range of numbers is that is coming in so we can translate that number into something more meaningful like pressure, because we don't get signals in from the modules like 30 degrees and 50 RPMs. We get numbers like 16,420 that don't mean anything to us. So we need to know what those numbers are and what those numbers translate to. So jumping into the screen here, I've got just an empty project here with nothing other than one PLC already set up. And the PLC that I'm using is a 1511-1PN, although it doesn't really matter, but different PLCs are going to offer you different options of modules. So if you want to know where this one came from, it was the first 1500, and when you open that first one up, it gives you 3 options, and I just took the first one off the top, okay? So real simple. And coming over here, let's look at, we've got our digitals, which are, with a D, and we've got our analogs, which start with an A, and we're going to look at this analog in, analog out module. So this is a combo module that has some analog input channels and some analog output channels. And I'm going to just drag this processor right over here onto my rack and put it here next to the PLC. And now that I've got that, and now that I've got it highlighted blue, I'm going to come down here and click on Properties. And check it out. I've got my input channels 0 through 3 and my output channels 0 and 1. Okay, so this has 4 analog inputs and 2 analog outputs. When I expand this down, I can come down here and expand the inputs, and let's just do channel 1, and all of these channels work the same, all right? And for this, I'm just going to resize our window so that we can see a whole lot more of these properties. Now, to start with, up here at the top, let me get back up there. You see how parameter settings, I've either got from template or I can select manual. Now, from template means right now, out of the box, all of these channels are set up the exact same way. They come set up for voltage, positive and negative 10 volts, and if I want to just leave it that way, I can just leave it at this from template. But chances are we're almost always going to be going into manual and setting these up for different signals to process. So what are our options? We can actually deactivate this channel because we're not using it. Therefore, we don't want it to enter into any equations, use any power. We can deactivate the channel. We can use voltage, and then under voltage, we've got several different options. Millivolt signals, 1 volt signals, 1.5 volt signals. So it's a very configurable module here. Aside from voltage, we can look at current. We can either look at 4 wires or 2 wires. And that depends on if we want positive, negative signals. But typically, what we're going to be using, and at least what I teach and what I usually like to work with, is current 2-wire, which is a simple 4 to 20 milliamp signal. And with that, we know what our number range is going to be in the manual. So we're going to set whatever we want. Typically, it could be resistance. If we're using thermocouples or thermistors and things like that, we've got another configuration here, so we can set these things up to measure temperature. For this course, I'm not going to go into all the different configurations of these modules and what they all mean and what kind of devices they all work with. So we're going to keep it simple. And in this course, we're going to be working with 4 to 20 milliamp on a 2-wire transducer. Now, that is what I really wanted to show you in here, because once you know how to configure the input modules, you can probably already figure out how to control the output modules. We've got channel 0 here, from template, manual, voltage, everything should look very familiar. Now, aside from that, we know how to set up the signal, but how do we know what numbers we're working with? Well, in your documentation bundle, you've got this PDF file in here, and look at the name of this, S7-1500 AI 4X UI RTD TC. It's alphabet soup, okay? Well, if you can find that, that is the manual for that exact same module that we were just looking at. And let's scroll down here to the table of contents, and you see we've got text specs, dimensional drawings, and down here at the bottom, analog value processing. Man, doesn't that sound like exactly what we want? So let's go in here, and their manuals are very readable. They're very user-friendly. You don't have to have a doctorate in engineering to read these things. I've said it before. They're really good. So let's come in here and take a look, and we're going to find what our actual input range is. So we've got bipolar input ranges, unipolar input ranges. Coming down here, our voltage, plus and minus 10 volts, plus and minus 5 volts, 1 to 5 volts. Now we're getting into plus and minus 20 milliamp. Nope, that's not it. 0 to 20 and 4 to 20 milliamp. Well, 4 to 20, that's what we were looking for. So right here, we've got 4 to 20 milliamp. And from 4 up to 20, these are the values that we care about. And right over here, we can see what our decimal scaling values are. So when we're scaling for this module, we're going to be looking at a range from 0 to the number 27,648. So 0, when we get that from the module, that means we're getting a signal of 4 milliamps. And when we get a signal of 27,648, that means what's actually coming into that module is 20 milliamps. And obviously sending signals out from an output works exactly the same way. So that We can go through here and we'll find all the temperatures and everything else, but I'm not going to confuse you or bore you with all of that right now. It's in the manual. You've got it. If you need it for a different manual, you can go online and get it. All of their manuals are available on their website. So again, very convenient, very easy to use, and very simple to work with. Okay, so that's really it. That's what you need to know about setting up analog modules. Configure the channels one by one. You'll probably want to be in manual. You can determine whether that's going to be voltage, if so, what signal range, or current, if so, what signal range, or temperature or thermocouple, and if so, what type and what range as well. And once you do that, you're going to want to jump into the manual and see what those analog scaling values are. In this case, we're working with a 16-bit signal. So we've got like 32,000 values going down and 32,000 values going up, or was it 35? I don't remember. But a lot of values on the downside and on the upside. And when we're just working with the upside, obviously we've got, half of that range, but that's still a whole lot of resolution. So now you know how to find all that, you know how to work with all that. We're going to be using these values later in the course, although we're not going to be actually setting up I/O modules because, one, we're not working with physical PLCs, and two, whenever you set up actual I/O in your program, in order to manage those values, you have to go to a force table, which is just one more complication when we're trying to simulate and run programs. We would rather either do it all right there on the programming screen, or we'd rather manage those values at least on a watch table. So by using memory registers in internal global memory instead of setting things up on actual I/O channels, it makes the simulation a lot smoother and a lot easier, and it's a lot less complicated for us. So we can focus on learning the programming rather than bouncing back and forth between a bunch of different screens and not really being able to see the process happen before our eyes. So that being the case, we're not going to do any more in this course with setting up modules or reading manuals or anything like that, but I did want you to know how to do it, and now you do. So that's it. Let's get out of here.